talk a little bit about Fluxus. Well, I was originally asked to talk about Fluxus, which is a free software application that I've been writing for about 5 years. But instead of doing a sort of technical overview of it, I thought I'd just show you some of the things I use it for and some of the things I do with it. It's very interesting. And one of the things that Fluxus is kind of part of a wider culture of things, which is called live coding. And live coding is the act of programming in front of an audience and improvising code in order to make music or visuals. And so just to explain what that looks like, here's a script written in the programming language that Fluxus uses, which is called Scheme. And Scheme is a very old language. It sort of goes back to the 70s when it was invented. And I found it very good for doing the sort of describing visual kind of things. So this script just renders a shape on the screen. And the thing that Fluxus does is it doesn't separate the kind of visual thing that you're making from the code that describes it. So it's kind of rendered over the top. So the text, you can change the text. So I do performances. Generally, I do performances. I start from scratch and just write a script to start with a cube and then make it kind of dance to the music and stuff. So you can kind of change parameters to make things, just change numbers, but you can also sort of insert bits of code. So you kind of change the code to do different things to make it move and so on. And this is kind of a lot of what I do is just doing visuals like this. So I'll just be taking audio in and making things happen to music and building up the script live. And just to show you a bit more on the. Just get rid of that. So there's also an art group that's kind of been created to promote live coding as an art form. It's very self-important, and like any very self-important art group, it's got a very long manifesto. And so there's a few sort of key points, like giving us access to the performer's mind, to the whole human instrument, and show us your screen, sort of granting is dangerous. It's all about showing people what you're doing, so you're not hiding anything back. And live coding comes out of the computer music kind of world, where it's kind of seen as a reaction against the sort of computer music hiding everything you're doing, and you could be surfing the net or checking your email and no one can see what you're doing. And it's all about just projecting it for everyone to see. And yeah, live coding is not about tools. Algorithms are thoughts, chainsaws are tools. That's why algorithms are sometimes harder to notice than chainsaws. Anyway, the very important one is this one here. It's not necessary for an audience to understand the code to appreciate it, much as it is not necessary to know how to play guitar in order to appreciate watching a guitar performance. So you're not expected to actually understand the code. It's enough to see that something is being constructed in front of you and that the complexity of what you're seeing is reflected in the music or the visuals or whatever. So that's TopLab. That's toplab.org. This is the website. Going back to this, so my sort of take on live coding is been doing a lot of this kind of thing. But I noticed there are two sorts of mistakes that you can make, and it's mistakes that really make kind of improvisation interesting. And you can make mistakes where you can, you can get different results by, say, if I accidentally put that there, you get a different result just by moving the position of something, and I probably wouldn't have intended that to happen, and I might think, oh, actually that's kind of cool, I can build on that, and that's kind of what improvisation is all about, and that's a sort of an interesting mistake to make, is something that results in something more interesting. But there's also, with programming languages like this, I might miss out a letter, and then the whole thing stops, because there's been a syntax error, and I gave to have a look at what's going on, and there's these messages coming out, and that's a sort of a mistake that makes you panic, and it's all broken. It's very brittle. It's got a very you're kind of scared all the time that you might cause this to happen. So it's kind of got this this problem with it that you can get these things to just break everything. So I was interested in ways of making live coding a little bit more malleable and a little bit more visually interesting as well, because looking at text, I wanted to kind of move things on a little bit more. I also wanted to get away from the keyboard, because it's just like you're kind of on a computer like this and typing the keyboard. So I thought I'd try using a gamepad. These are very, very cheap, and you've got some buttons and some joysticks. And so I wrote another Fluxus script. This is all the same as the other one, it's just much longer. And this isn't important, you don't have to look at this, you just run it. And then you can hide it. And what we have here is actually a very, very simple CPU with 256 bytes of memory, so it's not very big. And with the gamepad, you can directly write into the memory. I'm not going to explain too much about programming language. And it's this sort of form of a kind of assembler. Some very powerful laptop speakers. So you can write these little programs, and
what part do you do?
I think I'll do it unplugged. There's a certain problem with this that I'll talk about. So this program is, the important thing is this program is actually modifying this one as it's running. So all these programs, unlike when you usually run programs on your computer, they're all in isolated kind of bits of memory, they can't talk to each other. With this one, they can all write over each other. So just to give you an example of that, you can load in a sheet and load in another program that I've already written. And this program, what it's doing is copying itself to another position in memory. So it's just copying over memory with itself. And when it's finished running, the program, none of these programs actually stop. They'll just fall off the end of the program, then start running and copy it to this name, and then start copying itself again. And this is, in Unix, this is called a fork bomb, where a program process keeps copying itself and fills up memory. So this one eventually writes over, so that's written over this process. And keeps on copying itself, and it's going to overwrite this one as well. So the whole thing gets very chaotic. It gets very difficult to tell what's going on, but that's kind of the point. You just whatever you do, you can't break it, essentially. Unlike when you're typing text, it's just doing its own thing. So let's just try to leave something else up. So one of the problems with this is when I'm not doing a very good job of this, but when I'm performing it live, performance is usually falling into one of two categories. You're either fighting it to keep it going, keep it making noises and it'll stop, or you're trying to make it a little bit more structured and not just make all the noises at once. So it feels more like you're fighting it than you're actually kind of programming it or thinking about it. So So yeah, if I just so now I started working on something else, and this program is, again, it's just another quite long script that's all written in this language that Fluxus uses. And this project is called Al-Jazari, and Al-Jazari was a 13th century inventor and scientist, and he invented lots of stuff that we use today, like crankshafts, and he invented lots of irrigation systems and really useful things. But one of the things that he did while he was busy doing all this useful stuff is he invented humanoid robots that played music at royal drinking parties. And I thought, this is really cool. I'm going to write a live coding system that's sort of live coding for royal drinking parties using robots. So it's kind of a similar interface to Beatblocker. It's all sort of cubes and squares and stuff. But you can place robots into this world, and when you start with a robot, his mind's kind of empty. He's not thinking much. But you can go in there and you can change. You can write code in his brain, and he moves around. And you can also place these markers on the environment. And when he moves over a marker, he triggers them. And you can move the markers up and down as well, or the blocks up and down. So you should put different samples. Anyway, so a bit less. And you can then double up and get doing something similar. So yeah, this was kind of designed. There's a lot of live coding performances for kind of in pubs and stuff for lots of art students. So I thought if I sit there and do lots of text and type out lots of code, it's just not going to go down very well. So this turned out to be quite popular. But I did a bit more complicated things. So look at that one here. So they've got lots of instructions. So if anyone's used so far, just move them around. So you've got move forward, back, rotate, left or right, and this is one which causes them to make a signal. So it's stimulated by the light bulb. And then you can get other ones. So they can basically send signals to each other. So you can say, this one says, so if there's a signal, then do something else. One of the things that makes this possible is using a ring menu with the joystick, so you can select lots of different options. Just makes it a bit more interesting from the one. you could do some quite complicated things. So you could also get robots to scan their local environment, see if there are any other robots around. And if you do, you can use this to make robots follow each other around and things. Let's see if this will work. So this guy's now scanning his environment and trying to basically, so one of the things is robots can't move into each other, they block each other. So you kind of get, after a while, you start to get more and more chaotic things happening, so they're just blocking each other or they're reacting to each other's presence. And the last thing to show is get one. So you can actually see the world from their perspective and follow them around. Yes, so that's it from this. So I've been doing a bit of this later on, performing this along with some other stuff. So. Now loaded. Some conclusions. So yeah, so to conclude, kind of in the context of live coding, these languages are very, very simple. There's not a lot to them, but they're very chaotic. And when there's too much chaos, it's hard to control. So that's kind of a bad thing. One of the things I can't decide if it's a plus or a minus point really is it doesn't look like programming. People don't tend to think you're programming, which on the one hand is kind of defeats the purpose in a way. It's kind of good because people want to have a go, they want to pick it up and see what it's like. And part of this is because if you use familiar objects like robots or kind of things like computer games kind of stuff, then it's familiar for people. And also, yeah, using a gamepad, I find it really good because you can get away from the laptop, you can kind of sort of shut it down, move it to the corner and play it just with the gamepad using the screen, and that means it's much less about a computer. Somehow it feels a lot better to me. So I think that's it for me. Are there any questions or anything?
Can I ask you something? Yeah. Can you export the sound or the graphical images?
Can you export?
Yeah, you can export them to, I don't know, to any format.
Yeah, so there's a way of, so with Fluxus you can save out the frames, so you can set up a sort of a script or something and then it dumps out the frames as you're doing stuff.
So in which formats you can export them?
So at the moment,
like in the video files in MPEG or AVI?
It's not, they're just frames, so just tons of JPEGs.
And what about the audio file?
So the audio is actually running on a server that I've written, which is a different application. But I've kind of just set up for doing that, so I can record the audio and the visual and then put it all together. And there's some videos I've got on YouTube which have done that way. And it's kind of nice because the system works so that you can do a live coding performance and record the key presses, and then you can later on render it up at much higher resolution, a much higher frame rate to kind of show people what you're doing. It's the same code, but you're sort of re-rendering the graphics.
But it's not general public license.
Oh yeah, it's all GPL. Yeah. All this is free software actually instead, yeah. It runs on Linux and it sometimes runs on the Mac, but I don't have one, so I can't support it very well.
So you got the website here?
Yeah, sure. It's actually the same as the main OpenLab. So ourselves, I'm also involved with OpenLab. But is the main website, but the application is there. And I should also say that OpenLab.org is OpenLab. And oh yeah, so my website.
My experience was that the very easiest way to get that up and running was to load up your die.
That's true, yes. It's also on PeerDye, which is brilliant, because I've done quite a lot of workshops. So teaching people who've never programmed before and getting them doing sort of reactive animations and stuff within a few hours. It's really good. And we use PeerDye for that a lot. So, also,
Which is the positive way of saying that I did find it difficult to install.
yes, it's not easy to install.
Positive thing is that you can plug in your PeerDye in and everything goes pretty well.
There are some definitely, there's an Ubuntu package, but it's not, I think it might work, but I'm not sure, I'm not the one making it. But it's, there's going to be, I think it's actually going to be on the main Ubuntu at some point.
Can you do network the Robot One and have musical robotic battles or something?
Sorry?
Could you network the Robot One and have musical robotic battles?
You could have multiplayer, and you could do that over a network. Well, I haven't tried that, but yeah, it wouldn't be too...
That might make it even more exciting for an audience.
Yeah. There's a sort of, one of the things, or one of the ways that people are looking to do one coding performances is to run this kind of as a fighting, a battling kind of thing, and that's certainly needs to be explored. Okay. That's
They're all expiring, so we better not change the one.
software is called yeah. Ski. So that's E. It's and it's based on this. It's a simplified version of this. Yeah.